All right, this is video 2.6 for Algebra 2. Today we're going to be taking those linear functions and seeing how transformations can affect your graph as well as your equation. So anytime you're going to have a horizontal shift, if it's going to move right or left, then when you have your function, there will be like a negative h. The negative, so it's going to move, if you want to move to the right, then it's going to be a negative. And if you move to the left, it would be a positive h. So for example, the equation f of x equals x, all of these I'm going to use the parent function, it goes straight through the origin, right? So if we were wanting it to move, we would do f of x equals x plus 2, and that would move it 2 places to the left because it is a positive 2. So instead of going through 0, 0, it would go right here. All right? Now, a vertical shift is going to be when you just add a k on the end of your factor. And that one is a positive k, so a positive number added will move it up, and a negative number will move it down. So back to our parent function here, if it's going through the origin at 0, 0, if you had f of x equals x plus 1, now instead of going through the origin, it's going to move up a spot, and it would go there. A reflection across the y-axis is going to be a negative function. So if you had f of x equals x, which is there again, a reflection across the y-axis would be f of x equals negative x, in which case it would flip and go that side. And a reflection across the x-axis, now with the parent function it's going to look exactly the same, but what's different about it is that everything would be in opposite. And so a reflection across the x-axis, it's not really a good example because it looks identical to the other, but if we were going to replace, let's say our function was f of x equals x plus 2, and we were wanting a reflection across the x-axis, then it would be a negative x minus 2 is going to bump it down across the x-axis. So let's practice translating and reflecting some linear functions. So we're going to let g of x be the indicated transformation of f of x. What we're looking for is the rule for g of x. So we have f of x is 2x plus 3, and we want to translate that up 4 units. So remember, a vertical translation is changing that number right there. So the way we would do that is we are going to take our f of x and we're going to add 4 to it. So we're going to have 2x plus 3, that's our f of x. We're adding 4 to it, so our new equation would be 2x plus 7. Let's say we have this table defining our linear function, and we're wanting to reflect it across the y-axis. So reflection across the y-axis means that we're going to take our y values here, we're going to replace the x with a negative x. So what we're going to do first is we're going to find the equation for this graph right here. So we're going to start with finding our slope, which is going to be our change in x, our change in y over our change in x. So when we go to 0 to 2, that's a change of 2. From 2 to 4 is a change of 2. So our change in y is going to be a 2. Our change in x, we go from negative 1 to 0, which is a 1. And from 0 to 1 is a 1. So our slope is 2. If we put in, if the x value is negative 1, then our corresponding y value is 0. So we could say y minus 0 is equal to 2, x minus negative 1, or y equals 2x. Okay, just dropping the 0 since it doesn't make any difference. 2 times x is 2x. 2 times negative negative 1 is a positive 2. So this would be our equation. What we're wanting for our rule for g of x, reflecting it, is that we are going to replace x with negative x. So it would be y equals, instead of 2x, it would be negative 2x plus 2. So that would be our equation. So if you're given the equation, all you need to do is make the change. If you're given a table, you've got to find the equation before you can make the change. Stretches and compressions. A horizontal stretch or compression is going to be by a factor of b. So what that looks like is you would multiply your x by the b. So horizontally is going to change the x factor. So if b is greater than 1, it stretches away. And if b is less than 1, and that just means it's a fraction, it's between 0 and 1, it's going to be a fraction, that is going to make it go toward. So for example, if I had a parabola, and this is linears, but let's do a parabola. If our b was greater than 1, it's going to come out wider. Okay, and if our b is less than 1, it's going to come in narrower, horizontally. So for a linear, instead of being, oh, that was a bad line. Instead of being here, coming toward the axis, the y-axis, if it's going to be a fraction, it's going to be a steeper line. And if it's greater than 1, it's going to be a flatter line, moving away from the y-axis. So you can look at the slope of that and see how it affects it. A vertical stretch or compression is going to be by a factor of a, where you're not just taking the x and multiplying it by the factor of 1 over b, you're taking the whole entire equation, the whole entire function, and multiplying it by an a. If your a is greater than 1, it's going to move away from the x-axis, and if it is between 0 and 1, it'll move toward the x-axis. All right, so let's do some. We have g of x. We want to do a horizontal compression of the f of x 2x minus 1 by a factor of 1/3. Okay, so we are going to, if it's a horizontal compression, we're going to use 1 over the factor. So we want 1 over 3, which would be a factor of 3. Okay. So I'm going to take my x, and that's what I'm going to multiply by 1 over 3. So 1 over 3 is the same thing as 1 over 1 times 3 over 1, which is 3. So I'm going to say it's going to be 2 times a 3 times the x minus the 1. So my new rule is going to be 6x minus 1. So remember, horizontal affects only the x. Vertical is going to affect the whole thing. Let's do a vertical shift of f of x equals x down 2 units by a vertical stretch by a factor of 5. So we're going to do them in order. We're going to go down 2 units, and then we're going to vertically stretch it by a factor of 5. And the reason we need to do the down before we do the stretch is because the stretch affects everything. The down only affects the up and down. All right? So we have our f of x, and we want to move it down. Instead of f of x, I'm going to write it as g of x. So g of x is going to be f of x down 2 would be negative 2. Okay, so then I'll have g of x equals, my f of x is x minus 2. That's my first transformation. Now I need to do a vertical stretch of 5. Remember, a vertical stretch affects everything. So I'm going to multiply all of it by 5, giving me a g of x is equal to 5x minus 10. So that is our new rule for g of x. That's it for today. Have a good evening. I'll see you later.